Let's take a look at this example, the Heaviside function h. So you can see h of t is 0 if t is less than 0, and h of t is 1 if t is greater or equal to 0. If I want to draw this function, it looks like this. So for the top part, it's right here, and for the bottom, it's right here. So you can see that as t approaches 0 from the left, and that's how we write from the left. H of t approaches 0. Now as t approaches 0 from the right, h of t approaches 1. So there's no single number that h of t approaches as t approaches 0. Therefore, we can say that the limit as t approaches 0 does not exist. So we just write D and E. All right. So that's the definition of the one-side limit. So you only look at the limit from one side. So you see part A, this is how we define the limit as x approaches A from the left. And then for part B, x approaches A from the right. Okay. Now, notice that the limit does exist if and only if the left and the right are the same number. The limit from the left and from the right is the same number. Okay, so let's take a look at example 7, and that's the graph of the function g. Now, let's take a look at part A. So for part A, I'm looking at x approaches 2 from the left, right there. And you can see that the limit is 3. Now, if you look at x from the right, x approaches from the right, which is this part, the limit now is 1. Okay, so you see part A and part B, they're not equal. So for part C, we don't have it, D and E. Now, let's take a look at number 5. X approaches to 5 from the left, this part. And the answer is 2. That's the limit. Now, if you want to look at the limit at x approaches 5 from the right, the limit now is 2. So you can see that it approaches the same number. So the limit x approaches to 5 is 2. Notice that g of 5, in fact, is, I believe, is 1. And it's not the same number as the limit, but it's okay. As long as we have the limit from the left and the right, and that's the same number, we have the limit.